Okay, guys, example 2 for week 5. So Mr. Tyson is considering 2 different routes for his morning commute to work. He would like to know which of these routes is faster on average. Over one semester, he randomly selects 45 days to take the first route. On the other 44 days, he travels the second route. The average commute for the first route is 18.4 minutes with a standard deviation of 3.6. The average commute time for the second route was 21.2 minutes with a standard deviation of 1.9. Construct and interpret a 99% confidence interval for the difference in the mean commute times between the routes. So we're trying to figure out which route is faster. So in our state, the first thing that I'm going to do is I'm going to say that we're going to let mu sub 1 equal route 1. And we're going to let mu sub 2 equal route 2. So we're trying to figure out which route is faster. So the first one is pretty nice. It has a mean of 18.4 with a standard deviation of 3.6. So if you add and subtract that, he's going, it takes about 14 to 22 minutes. Whereas the other one, it's an average of 21 minutes with a standard deviation of 1.9. So that's going to take him anywhere from 20 to 23 minutes. So we want to figure out on average which one is faster. So the first thing that we're going to do is look at our null hypothesis. Your null hypothesis never changes. It's that there is no difference. The alternative hypothesis is that one is faster. We don't know which one though. So we're just going to check to see if there is a difference. Okay, so then we need to figure out all of our good information. So what is n sub 1? And if you look right here, it says he selects 45 days to do route 1. So n sub 1 is 45. The other 44 days, he goes the second route. And it says the average commute time for the first one. So average time was 18.4. So x bar sub 1 is 18.4. X bar sub 2 is 21.2. The standard deviation for the first one is 3.6 and the standard deviation for the second one is 1.9. We also have our confidence level is 99%. We can figure out the degree of freedom. So with the degree of freedom, we're going to do n minus 1, and we're trying to figure out which sample size is the smaller number. 44 is smaller than 45, so whenever we're looking at the degree of freedom, we're going to do 44 minus 1, which equals 43. So now we can figure out what T star is. What is our critical value? So in our table B, we're looking at 43 is the degree of freedom, but it goes from 40 to 50, so we're just going to look at the line of 40. And then we have 99% is our confidence level. So right there we have our T star, which is 2.704. 2.704. Okay, so let's go ahead and jump into plan. So we've done all that we can do in this state. We're going to go ahead and plan. The first question is it random? And yes it is. It says he randomly selects. So right there in the problem we know, yes, it's random. The second thing is, are the sample sizes greater than 30? And yeah, they are. So is n sub 1 greater than or equal to 30? Is n sub 2 greater than or equal to 30? We have to check both. So 45 is greater than or equal to 30, which is cool. And 44 is also greater than or equal to 30, so that's good as well. So this is normal. Let's write like a normal person. There we go. Normal by the central limit theorem. Central limit theorem. Okay, moving on. Do. We're going to go ahead and plug everything into that formula. Again, that formula is x bar sub 1 minus x bar sub 2. plus or minus t star times the square root of s sub 1 squared over n sub 1 plus s sub 2 squared over n sub 2. So let's plug everything in. So we have x bar sub 1, 18.4 minus x bar sub 2, 21.2, plus and minus t star, 2.704, times the square root of 3.6 squared over 45, plus 1.9 squared over 44. And again, we're going to plug this into Desmos, so that way we can get our answer. So we're going to go ahead, click over to desmos.com and type it in. So 18.4 minus 21.2 plus hold on. Yeah, 2.704 times the square root. Can y'all hear the airplane? Y'all can't actually answer me. There's an airplane that is attempting to break the sound barrier. I think it's doing a pretty good job right now. Yay, Ellington Field. 1.9 squared over 44. Okay, so our first number is negative 1.155, which is about negative 1.16. And our second number is going to be, I'm going to go ahead and change that to a minus sign, negative 4.44. So the low number is going to be that negative 4.44, and the high number is negative 1.16. So this is saying that route 1 is going to be anywhere between 4 to 1 minutes faster than route 2. So we have to put that into our conclusion. So let's go ahead and fill in those blanks. Okay, so we are 99% confident that the interval from negative 4.44 to negative 1.16 represents the true change in average of drive times to work. We're going to change this to from route 1 to route 2. The interval suggests that it takes that, we'll do this, route 1 is 4.44 to 1.16 minutes faster on average than route 2. Okay. And there we have our problems. So if you look at all of them, it's the same step for everything. So you start with your state, your plan, your do, your conclude. They are nicely color-coded so that we can kind of see them side by side, how every single time we do the same stuff, just different numbers, putting in different things into the formula. Whenever you are ready, go ahead and fill out the Google form in the classroom, turn it in, and so that way it can be graded. Have a great day. If you have any questions, remember, email me. Please do not leave a comment in the Google Classroom private message thing under the instructions, because those are really hard to find. You can also send me a message in Remind 101. Have a great day. Bye.